Now that we reviewed inequality symbols and wrote some inequalities, now we're going to find and interpret solutions to the inequalities. Here's some values for y that are solutions. Y could be 9, because that's less than or equal to 9.2. Y could be 7, y could be 5. Y could also be exactly 9.2 because of the equal to part. I do want you to sketch a number line. You don't have to label everything like this one, but when we show these solutions on a number line, what we're going to be showing is we're going to start with that 9.2, and it's less than or equal to, which means it's going to be a closed circle right there. And that's because it's less than or equal to is the important piece right there. And our solutions are everything less than that. And so I'm going to draw an arrow going less than that, showing that every single number on the number line, all the decimals, all the fractions, everything in here is included in that solution of being less than or equal to 9.2. We're going to use this problem to start walking through the steps of how to solve an inequality that looks like this. So I've rewritten the inequality, but I'm going to make one big change. Instead of a greater than symbol, I'm going to make it an equation with an equal sign. So when I worked through all the steps here to solve it, I got x to equal 1. So what I'm going to do is I'm going to put a circle here on 1. I know it's an open circle because it's just a greater than symbol, not greater than or equal to. So I'm going to leave it an open circle. And now I have to decide which way are the solutions going to lie. Are they going to be the numbers that are greater than 1, or are they going to be the numbers that are less than 1? You're probably already noticing that your solution is on one side of this point, but here's what we're going to do. We're going to pick a number on each side and test it out. So I'm going to pick a number that's maybe a little bit easier. I'm going to pick 3. I'm just going to put a little dot here above it. So that means over here, I'm going to plug in 3 for x, and I'm going to see what happens. I get 7 times 0. Anything times 0 is 0. And so I end up with 0 is greater than 14. That is not a true statement. That does not work. So I'm going to try a number on the other side of my circle. I'm going to try 0. When you're doing this, pick things that are easy. You can really pick any number, but the easier the better here. And now I plugged in 0 for x. I'm going to simplify, and I end up with 21 is greater than 14. Yes, that is true. And so I know that all my solutions are going to lie in this direction. So on the number line, I have now put my boundary, which is 1 that I got from solving it like an equation. And then I found that all my solutions were on the left side of that boundary. Okay, this information is written out in your book. I'm calling it the Amazing Apple Orchard. That is Apple Orchard A. And then the best apple orchard is apple orchard B. The same information that's in your book, like I said, and you're going to figure out the cost of taking these numbers of students for each apple orchard. Looking at these costs for the different numbers of students, I do start noticing that apple orchard A is more expensive until we get up to 30 students. So I am wondering, at what point between 12 and 30 students does Apple Orchard A become less expensive? To help compare the cost, the teacher first writes this equation, and just take a minute and figure out what is going on in that equation. So as you're looking at that equation and inequality, you're noticing that n is representing the number of students. In B, in this situation, what does this equation mean? Well, it's telling us at what number of students would the cost of the two apple orchards, because this side is apple orchard A and this side is apple orchard B, would the cost be equal? And then C is telling us when would apple orchard A be less expensive or less than apple orchard B. To solve this inequality, the first thing I'm going to do is rewrite it with an equal sign, so I solve it as an equation. I end up with n equals 17, But that's not the solution to the inequality. That was the solution to it as an equation. But on my number line up here, I'm just going to add 17, and I'm going to put a big open circle on it. It's an open circle because this was just less than, not less than or equal to. But now I need to decide, is my arrow for my solutions going to go to the right or to the left? So I'm going to choose 20 on the right and test this. So I plugged in 20 for n, and I have to decide if it makes this inequality true. When I plugged in 20 for n, I ended up with 207 is less than 210, and yes, that is true. So that means my arrow is going to go in this direction to the right. And what that means is that any number of students greater than 17 is going to make Orchard A less expensive than Orchard B. We're going to practice solving another inequality, but first we're going to solve an equation that goes along with it. In solving this equation, my first step would be to multiply both sides by 5 because that's going to get rid of your fraction. When you do that, those 5's cancel out and you're left with this to solve. When I plugged in 0 for x, this is my work. When I simplified, I ended up with negative 2 and 2/5 is less than or equal to negative 12. And no, that is not true. For a value greater than 2, I plugged in 3 for x. And here's my work. When I did that, I ended up with negative 4 and 4/5 is less than or equal to 0. And yes, that is true. When I plugged in 2 for x, here was my work, and when I simplified, I'm left with negative 4 is less than or equal to negative 4. And yes, that's true because of that or is equal to part. Now to graph our answer on the number line, we're going to put a closed circle at 2 because we found that to be our answer when we solved it as an equation. And we know that it needs to include 2 because of the less than or equal to part. And then we found that all of our solutions lied where the values were greater than 2. So that means this side going to the right is going to be where our solutions are. So we'll do an arrow to the right that way. So to wrap it up, when you're solving an inequality, solve the equation first, and then pick a value that's less than that, pick a value that's greater than that, and see which one works. And whichever way works is the direction your arrow goes.